All right, hello. Okay, this is the second topic for forces, where we're going to be looking at the different kinds of forces. Now, there are a lot of different forces we're going to talk about in this, and the different classifications and kinds, and a lot of stuff. But we're going to start off with some real quick review from the last video, which is what is a force? Okay, so force, as we defined it the last time, is anything that induces or causes an acceleration. So anything that causes something to change its speed or change its velocity, that's force. Okay, that is a very loose definition of a force. You've probably heard it defined as a push or a pull, and that is not wrong, but much like the Newton's third law description that we talked about in the previous video, this is not very accurate either. So this is a little more precise. These are the two that I'm going to be kind of expecting you to know. This is the video. This is the one from the previous video. This is the same thing, but acceleration, remember, is a change in velocity. So these two statements say the same thing. They're just phrased a little differently. Okay, standard units for forces are newtons. Okay, named after, the dude that we spent a lot of time in the last video talking about. We do not generally use pounds. Pounds is the American or English unit for force. We're not going to be using pounds very often. There are some calculations at the end of the unit where we'll talk about converting back and forth between newtons and pounds, but we'll save that for them. You will need this conversion factor when we get there. 1 pound is 4.45 newtons. Okay, so now on to the actual topic that we care about today, which is types of forces. So the types of forces fall into a couple different categories. There are a few ways to divide up forces. Okay, you can do forces that are pushes versus forces that are pulls. You can do contact forces versus field forces. There are a couple other different ways that I'm not even going to get into in this. Okay, but we are going to be using contact versus field. And this is exactly what it sounds like. A contact force is a force that requires physical contact in order for that force to be transmitted. Okay? You cannot move the chair unless you touch it to grab it and apply that force. Okay? That is a contact force. Field forces are forces that do not require contact. Okay? So they can act over a distance. Okay, the most obvious example of this is gravity. Gravity does not require physical contact. The sun does not touch the earth. Thank God. Okay, if it did, then we wouldn't be here, for one. But that force that it's exerting on us, that gravitational force, is acting despite the massive amount of hard vacuum that exists between us and the sun. So that would be a field force. Okay, so those are our two classifications. We're going to talk about those periodically throughout. The main thing that we want to talk about today, though, is our fundamental forces. Now, I don't know who decided these were the 4 fundamental forces. I do not know. That is not information that I have to give you. I can tell you, though, that what these really are is they're the 4 field forces. These are the only 4 forces that are field forces. There are many other forces besides these, but only these ones are field forces. Okay, the first one we've already talked about, the gravitational force, or the force of gravity. Okay, it's an attractive force between any objects that are composed of matter. It has to be attractive. There is no repulsive end of the gravitational force. It always pulls things together. It does not push things apart. Okay, the electromagnetic force is one that you may have heard of before. It's kind of in the name. Electricity and magnetism. Okay, electricity and magnetism are the same force. We talk about them separately, but they really are the same thing. They just interact in different ways depending on the specific situation they happen to be in. Okay, now unlike the gravitational force, the electromagnetic force can be attractive or repulsive. So it can pull things together or it can push things apart. Okay, and that's going to be between any charged particle. Okay, charged particle, that's your key here. Wow, okay, I didn't mean to do that. So gravitational force, that's between things made of matter. Electromagnetic force is between charged particles. The strong nuclear force is the force that holds the nucleus together in an atom. Okay, we talked way back when about how kind of ridiculous it is that nuclei exist. We've got all these positive particles packed together into the smallest possible space you can possibly imagine, and they want nothing to do with each other. The strong nuclear force is why they stay together. Okay, the strong nuclear force holds atomic nuclei together. It also holds aggregate subatomic particles together. So this has two functions. I'm not going to go into the second one very much. You just need to know it. I don't think you guys want to talk about hadrons versus bosons or baryons. That's the word, not bosons. Baryons and hadrons and all the different kinds of quarks. We're not going to get into that in this class. But strong nuclear force holds those together, and it keeps atomic nuclei together. Okay, and then the weak nuclear force is the force that actually governs radioactive decays. Okay, so most radioactive decays, the reason they take place is the weak nuclear force. We're not getting into that. Again, we're not doing too much with these two. Okay, this one is radioactive decays, nuclei, and aggregate particles. This one's between charged particles, and this one's between things made of matter. And that's all we're really going to do with this. I would highlight or underline those things on each of these so that you can find, like, that's the key difference. That's the stuff you have to know. Okay, and the last thing that we're going to spend time on today is our three flight forces. Now, I call them flight forces. This is my... What? What are we doing? Go away. This is my attempt to kind of come up with a bit of a nickname for these so that we can distinguish between them. We can call them flight forces. They're really just common day forces that we're going to spend a little time on. So those three forces, two of them are actually flight forces. Drag, thrust, lift are the three forces. I didn't list those in order for some reason. Thrust is any force that is propelling something forward. Okay, now specifically, when we talk about thrust, we are not talking about a car engine. Okay, now a car engine can provide thrust, but it's doing so in a roundabout way where what it's actually using to push the car forward is friction. But we'll talk more about that later. When we talk about thrust, we're talking specifically about the expulsion of gases to push something forward. Okay? So that might be something worth writing down, because that's not on here. Okay? It's an expulsion of gases that pushes an object forward. Think about a rocket or a plane. Okay? They're burning fuel, creating to create a gas that pushes that plane or pushes that rocket in whatever direction it's going. Now, yes, those gases happen to be on fire a lot of the time for a rocket and not on fire for a plane, but still, that's what's pushing that forward. By the way, this is something you need to know. Okay? Regarding plane tires and plane wheels. Okay? You need to know this for the next thing we're going to do when we start doing free body diagrams, but I want to spend a little time on it here so it's not brand new then. Okay? Plane tires do not push or pull a plane anywhere. Okay? They have no ability to do that. All they are there for, they're free spinning. Okay? They are not drive tires. They are guiding tires. Okay? The purpose of those is so that they can make sure that the plane is cushioned when it's on the ground, and so that there's wheels so that it can move forward. But what actually causes the plane to move is the engines on the wings. Okay, or if it's a prop plane, then obviously the engine there. But the propeller is what pulls that plane forward. Okay, propeller pulls it forward, or engines push it forward, but the wheels do not exert a force to push that plane in any direction. Okay, that's going to be really important in a couple of videos. Not so much in this one, but I wanted to mention it while we're talking about thrust, because, yeah, plane tires don't function like car tires. The next one is drag. Drag is really simple. It's just air friction. We tend to ignore air resistance in most physics problems that we're doing, unless it becomes so egregious to do so that we just can't justify it. And when that comes up, like, we'll tell you, hey, you need to actually account for the air friction here. When we're drawing diagrams, you're going to have to acknowledge air friction, which we'll get more to that later. But anything that is moving through the air is experiencing air friction. Okay, just imagine if you've ever, and I'm sure you've all done this at some point, roll down the window in your car, stick your hand out the window, and when it's out, as soon as you put it out the window, you feel it get jerked back. Okay, that's the air friction. That is the drag of the atmosphere trying to stop you and your car, for that matter, from moving. Okay, one of the big design things you have to keep in mind with cars or trucks or anything is aerodynamics. You want to make sure that it cuts through the air or minimizes the air friction as much as possible, because by doing so, you increase your fuel efficiency because you don't have to work as hard to get up to speed. So drag is just a really fancy way of saying air friction. That's all it is. Okay, and the last one is lift. Now, you've probably all heard of lift, but most of you probably don't actually know how it works. So I'm going to draw an airfoil and kind of show you. But this is a force that actually pushes a wing up. Specifically, it pushes an airfoil. Oops, okay, I need to turn the pen on before I can write. Okay, it's going to push an airfoil. Now, an airfoil is a specific shape that we're going to talk about. And because of how it's shaped, it creates a partial vacuum to cause the airfoil to either rise or fall. Okay, in planes, obviously we use it to rise. The faster the plane goes, the more lift it experiences. In race cars, though, they will put an airfoil upside down on the front end of the car to make sure that the car gets pulled down to the ground so it doesn't try to take off. A lot of Indy cars drive much, much faster than planes do when they take off. So they actually had a problem with the cars coming up off the ground. And then you have no control of it. You're a projectile at that point. You can't steer your car in the air. And so they put airfoils on the front of the car, and it sucks the car down to the ground, just like the airfoils on the plane's wings cause it to rise. So it has the opposite effect for the same reason. Now, the shape of an airfoil is pretty simple. I'm going to try and draw it. Actually, I'm going to pause this to draw it so that you don't have to watch me struggle through this. All right, so here is my airfoil. So this is basically a cross-section of a wing. So if you imagine a plane going this way, okay, this is the cross-section of the wing. Okay, and this shape is called an airfoil. Now, what happens here is, because if you look, it's a longer path for the air going over the top of the airfoil than it is for the air going under the airfoil. So what that causes is the air on the top ends up kind of thinning out for an area just above the top of the wing, and it creates a partial vacuum above the wing, above the airfoil. And so what that does is it starts pulling up on the wing. And so the wing starts trying to rise because of this partial vacuum. Okay, so the air under the wing pushes it up, and the air above the wing kind of sucks it up. The faster you go, the greater this effect becomes. So as you fly faster and faster and faster, or as you move faster and faster, you get more lift, which causes you to come up off the ground. And that's pretty much it. Anytime you have a plane or space shuttle, the space shuttle uses lift as well, but all planes use lift in order to fly. There's a quote in the book that plane is basically using a loophole in physics to cause it to fly through the air, which is an excellent observation. It's 100% true. But that is pretty much it for this. Thrust, drag, and lift are the three flight forces. Drag is not exclusive to planes, though they do have to deal with it. But yeah, that's it for this video. There will be a part 2 to this where we talk about more contact forces. Some of the more common ones you've probably heard of before. But this video is already almost 20 minutes long, so I'm going to go ahead and stop here. So have a good day, and I will see y'all next time.